Next, more details of our project will be given in the following part, which includes 5 parts. As we all know, birdwatching is not only a visual behavior, but also an aesthetic activity involves senses from visual, auditory, and tactile. The relationship between tourists and birds becomes closer in the park. Parents and children, photographers will all come for birdwatching. Therefore, we try to build a birdwatching platform for photograph, rest, and fun. The site is located on water, windy and exposed. We take inspiration from the wind, birds, and the shape of the bamboo forest, and we explore the possibility of creating a light, floating, hidden bird watching space by using a multi-layered, suspended downward growing bamboo. To realize this concept, we use grasshopper to simulate the catenary. A dome space provides shade and rest functions. At the same time, it opens up the field of vision for bird watchers and forms different shooting frames. The hidden structure is eliminated by using laminated and downward growing bamboos. We also try to bring sounds into the construction through the interaction between hands, bamboo, and the wing. Bamboo sings with birds, introducing a new sound to nature. The following part is about the challenges and solutions we have encountered from the preliminary to the final. We use a simple orthogonal grid in the construction of the 110 model of the preliminary competition, which leads to instability of the whole structure. Besides, the single-layer grid became obviously deformable under the load of up to 900 bamboo strips. Therefore, in 110 and 1.3 model building phases of the semi-finals, we focus on the design of enhancing the stability of the support system. We first changed the original orthogonal system to a 3-dimensional 3-layer grid to make it consistent with the 3 supporting columns more unified. The 3-layer stacking also solves the serious deformation of the single-piece grid. In order to better cope with the challenge of wind load, we optimized the supporting structure and the grid nodes at the same time, turned the columns into clusters. We also tried to make stronger suspension nodes with resin and added horizontal bamboo beams and diagonal bracing. On-site construction has turned theory into a real challenge. In order to hold more than 600 kilograms of bamboo and ensure stability of the overall structure. We designed steel sleeves to strengthen the supporting nodes, but to make the form of the bamboo structure and the materials greener, we changed the steel sleeves into a triangle ringed beam of bamboo, and the beam was tied to the grid to make the entire supporting structure a whole triangle system. However, the resin node envisaged in the semi-finals was abandoned because of the complicated process. Therefore, we use wire and hook nodes, which can be made and replaced easily. Besides, to enlarge the cross-sectional area to enhance stability, we add short columns in the center of the three supporting columns to form a cluster. Moreover, we use the reinforced concrete filling method to hide the base under the ground, making the whole structure float in the air. The completed floating bamboo becomes more dynamic than the 1-3 model. It is not a device for people to fiddle with, but a construction that can respond to the wind. Too much decoration has become meaningless. Time talks, and the floating bamboo will follow our original intention, slightly moving with the rhythm of nature. Let more people hear the sound of the wind.